Let's now backtrack and look at example 2, just as another example of F-statistics, p-values, ANOVA, and just parsing all of this information. So this one says the University of Chicago's General Social Survey is the nation's most prominent social science survey. In 2014, they asked a random sample of adults their highest degree earned, whether it be high school, junior college, bachelor's, or graduate degree, and then where they place themselves on the political spectrum using a 7-point scale. Kind of like how I asked you guys at the beginning of the semester, what's your political affiliation, where 1, 2, 3 means you're liberal, 5, 6, 7 means you're conservative, and 4 means you're indifferent or in the middle. And they wanted to kind of know, did the level of education affect basically how conservative or liberal the person was? So kind of like, did education influence, political beliefs or whatever? First question asks us, what is H sub 0 and H sub A, the null and alternative hypotheses? But just like last time, and just like always with chi-square distributions and F distributions, the null hypothesis will always be that there is no difference in the population. So here, again, we can see there's a graph of the kind of the outcome, and basically it says it's the mean political spectrum score. And for high school, it looks like we're getting a value about close to 4.2. Junior college or community college is more appropriate these days, more like 4.1, 4.15. Bachelor's degree is somewhere about 4.0 to 4.05. And graduate is more about 3.7 or 3.8. So it appears that graduate has a slightly smaller, is a little bit more liberal, and that high school and junior college educated people are a little bit more conservative, not extremely. And again, 4 is kind of like right down the middle. Looks like bachelors are, pretty close to being right down the middle of the spectrum. And basically, we have 4 different groups here. So we'd be looking at the mean political spectrum score for 4 groups: high school, junior college, bachelor's, graduate. So we'd say this is X bar 1, X bar 2, X bar 3, X bar 4. And we've kind of been given that information already. And so our null hypothesis would be regarding the actual value for all high schoolers, and in Chicago or whatever. And so it would always be that each one of those is equal. So mu1 equal mu2 equal mu3 equal mu4. Or you could just write that in words saying that there is no difference between the means of the political spectrum scores, aka everybody has the same political affiliation score. It doesn't matter how educated you are. And then our alternative hypothesis here is that there is some difference. Remember, it's not that they're all different, it's just that some of them are different. Like maybe high school and junior college, they might be the same, but it seems though graduate is different from the rest at the very least. Again, we're not going to go into those finite individual analyses, but basically there is some difference. In mean political affiliation scores. And again, we could go through the process of determining this. And to do ANOVA, again, our goal is to sort of set up our statistic. Again, the reason we need to use ANOVA is because we have more than 2 populations that we're looking at. Again, our goal would be calculate the test statistic, which, because ANOVA always uses an F distribution, so we're trying to find F. We would only ever do that using software. And we don't have the data, so how on earth could we do it anyways? So in this case, it says, assume that we calculate the ANOVA F statistic. Again, this will be how some of your homework will be, or a test question where here's your F statistic. And it says, let's say you obtain an F value of 7.59 with a p-value of 0.000. So if you're like, well, p-values, they're not 0, they should be 0. But let's just say it's like 0.003 or something. But basically what that's saying is it's very small. But it says, based on the graph and the F test, what do you conclude? So remember that high F statistics, as I said in the last video, indicates, and again, you might wonder, well, what does high mean? Well, we don't really know. It depends on the context of the degree of freedoms and everything else that we don't know. But given that we were told the p-value is very, very small, less than 0.01, we know that that is going to be less than any standard alpha for a significance test. So since our p-value is less than alpha, we conclude that we do have statistically significant evidence. So, we could say that we have statistically significant evidence to reject the null hypothesis, meaning that we reject the claim that all of the groups have the same mean in favor of the alternative hypotheses that there are some differences. Again, we could go into this more and say that based on the graph, it appears as though graduate students are different from the other three and maybe bachelors as well. But we can't do any, we could then elaborate and go into more statistical comparisons. Again, we'll save that for more advanced needs. But you can imagine how we could then go back and use a 2-sample test to compare specific groups from there. But we would not want to proceed with that if we did not get such a low p-value. And then number 3 says, let's assume that the standard deviation S1 of the first group, so this would be for high school students, is about 1.4, S2 is 0.9, standard deviation for college graduates is 1.7, and the standard deviation for grad students is 1.1. And remember, basically all these are political affiliation scores, and what this is saying is that each of these groups have some variation. It appears as though college students have the biggest difference in their political spectrum at 1.7, which on a scale of 1 to 7 is a pretty large variation. And then it looks as though community college students have the smallest variation of about 0.9. But basically going back to the rule of accuracy, our F-statistic is more correct or is best used when all of the standard deviations are similar. None of them are more than twice the others. And if we look at, basically, if you compare the smallest to the largest, you want to make sure that it's, it's not twice as large or more than twice as large. So, 1.7 is roughly twice as large as 0.9. It's a little less. So in this case, it's fine. It is no standard deviation is more than 2 times any others. So basically, our F-test is accurate enough for our purposes, and we can be happy with our conclusion.